So with each of the pieces of the piecewise function, you could think of them as their own little equations. Like the top row is y equals negative x plus 1. Remember how to graph that? That has a y-intercept of negative 1 and has a slope of negative 1, which means it goes down 1 to the right 1, or in reverse, you could go up 1 to the left 1. That's the graph of y equals negative x plus 1. But the only difference is that a piecewise function says, hey, you stop that graph at negative 2, at x equals negative 2. So here's where x equals negative 2 in my quick sketch. That means none of this should happen. Only this part of the line should exist. Okay? Because this graph is only graphed when x is less than negative 2. So let's make that happen with our piecewise function here. The smallest ones, the top one is always going to be the one to the left in Newton. Y equals negative x plus 1. This is going to be hard to graph. Positive 1. Oh, dang it. I did a negative 1. This is a positive 1 for y-intercept, so it should look like this. Okay. Sorry, some of you might have been pulling your hair out while I was making that graph. Okay, I did a y-intercept of negative 1 with my quick sketch. Sorry about that. Okay, so positive 1. Here, let's just put the dot over there. It can't happen. We can't actually have a dot over there because this is only when x is less than or equal to negative 2. But it's got a slope of negative 1, which means I could go up 1 to the left 1. Right? Because if you read this from left to right, you go down 1 to the right 1, down 1 to the right 1. So this is the graph of y equals negative x plus 1. But right now my graph exists when x equals 0, when x equals negative 1. The graph is only supposed to exist when our values are less than negative 2. So without changing the graph, I got to move these points so that the graph only exists there, without changing the slope of the graph. And that's it. Now my purple line only exists when x is less than negative 2. And then look, this helps you make it a solid dot or a open circle. It's open circle because it just says less than. If it said less than or equal to, then we make it closed dot. Okay, negative x squared. This exists between x equals negative 2 and x equals 1. So if it's x equals negative 2, it's a closed dot. That's already there. We're all set. We don't have to move that around. But then it needs to stop when we get to x equals 1. Right now the red graph exists at x equals 1, x equals 2, x equals 3. This one's too far. We've got to back it up. This red graph only exists between negative 2 on the x-axis, so between right here and right here, and positive 1. Now we've got it. I moved the graph. The last one, the one on the right, the blue graph, this is y equals negative x minus 3, so it needs to have a y-intercept of negative 3. And then it has a slope of 1, which means it goes up 1 to the right 1, up 1 to the right 1. So that's the right graph, except this is only supposed to happen when x is greater than or equal to 1. Right now it happens at x equals 0, and 0 isn't greater than 1. So we just need to shift it this way. Now we've got the right blue graph. This graph is a graph of y equals x minus 3 because it crosses at negative 3 on the y-axis. And it goes up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. It's got a slope of 1. Oops, I got something wrong. What did I do? Oh, this is an open dot. I missed that. Oh, it won't let me change it. Look, I moved it. It's not changing. That's so weird. That's a glitch in Newton, but it says not included, so hopefully I've got that right. Okay, this one's not included, this one's included. This one's not included, this one's included. This needs to be a closed dot down here because it says or equal to 1. So that shouldn't have been an open dot, it should be a closed dot. I think I got it now. Oh boy, what did I do wrong? Oops, I dragged this back. That should have been not included. Everything else is right in that graph. But that's good because that'll give me another one to practice here. Try to make it bigger. Okay, so remember, this is y equals x plus 1. So, oh, this one I just have to pick. That's not so bad. The graphing feature is the tough part. Okay, so when I make this graph, I do y equals x plus 1. So that's a graph of a y-intercept of 1, a slope of 1, up 1 to the right 1, up 1 to the right 1. So here's my graph of that top function. But this function is only supposed to exist when x is less than negative 2. So here's negative 1, here's negative 2. Everything other than this part of the graph needs to be canceled out, needs to be taken away. This is not part of the graph because the graph is only supposed to exist when x is less than negative 2. So this is the only part of that line that should exist. Okay. And then negative 2x minus 3, so we know how to graph that. That has a y-intercept of negative 3. And it rises 2, runs to the right one. Rises 2, runs to the right one. This graph only exists when x is greater than or equal to negative 2. So there's negative 2. When I make this sketch, I'm going to put a closed dot here and then draw through all those points. Right? So without my scratch marks, this is what it should look like. Here's at x equals negative 2, there's an open circle there because it says less than. And then there should be a closed dot somewhere down here. I wasn't very exact with my graph, but that was our other graph. Oh, wait. Oh, my gosh. I messed this one up again. Look, it's a negative 2. I was doing a positive 2 for a slope. I can't believe I did that. Okay, so let me just restart this. I'm very sorry. Okay, y-intercept of 1 for this top one. Slope of 1. Up 1 to the right one. So we can go in reverse. Right? But this graph only exists when x is less than negative 2. So here's negative 2. The graph is an open circle here, and only when x is less than negative 2. Okay, so that part was right. This part, I graphed a slope of positive 2. I can't believe I did that. So y equals negative 3 is down here. And a slope of negative 2 means I go down 2 to the right one. Put a dot. Or I could go up 2 into the left one, the opposite direction, put a dot. Up 2 into the left one, and then this is going to be a closed dot. And I'm not going to draw my line over here because this piecewise function, this line, only happens when x is greater than negative 2. So it's only like this. Okay, so there's our rough sketch. This one, what's wrong with this one? This one has a y-intercept. Look, the line that we drew over here, this one has a y-intercept of positive 3, but it should be negative 3, so that's not right. This one's definitely not right for many reasons. Doesn't look anything like our rough sketch. This one, it switches there. That's good. This one has a y-intercept of negative 3. This one might be it. Let's check the last one. Look, this last one has a y-intercept of 1. That's not correct. So this is our correct graph for piecewise function. Okay, this stuff's easy. Easier, I should say. Evaluate when f is 0. That means you're plugging in x equals 0 into the function. So look, this function says when x is less than 0, you use this one. But x isn't less than 0. X is exactly equal to 0. So that's this function right here. So plug 0 into this function and write out the y value. If I plug in 0 in for x, then that's all. There's no other funny business. It's just 0 for a result. Okay, same thing with this one. This means plug in x equals 3. We don't do it here because x is 3. It's not less than 0. We don't do it here because it's exactly equal to 3. It's not less than 3. This is the one we want to use. So 3 squared is 9. 9 minus 1 makes 8. Same thing here. Plug in 0. This is the one where x could possibly equal 0. So 0 squared is 0. 0 minus 2 is negative 2. Okay, that stuff. I have another video for that too, but. Oh, they want me to do more. X is negative 5. That's this one up here, right? Because x is less than negative 4. If you plug in negative 5 in for x, that's a true statement. It's false everywhere else where you plug that in. So that's 20 plus 1, that's 21. Okay, back to the graphing. Which of the following piecewise functions is represented in the graph below? So we can do that off to the side. That'll be quicker than just trying to match them probably. So from when x is less than negative 2, that's the first jump I see. Look on the x-axis. This changes when we get to x equals negative 2. And the y values are constantly 1. So that means for our piecewise function, all we have to say is the y values are 1 when x is less than or equal to negative 2. Okay, then it changes. When x equals negative 2, then we're between these two numbers, negative 2 and 1. Look, this is a line with a y-intercept of negative 3, and it rises 2, runs to the right one. So this is 2x minus 3. That's the equation of this line in the middle. And this line exists on the x-axis between -2 and 1. Closed out right there, so we need a line underneath. And then this line up here, it's down one to the right one, so this is a -1 for a slope. And if we were to go the opposite direction, up one, left one, it would cross at +5, so that's our y-intercept. This line only exists when x is greater than, I can't tell if that's a closed knot or not, greater than or equal to 1. So this, let's just check the first row, make sure that's right. This is right for the first row, this is right for the first row, this is right for the first row, this is wrong for the first row, so we can eliminate that one. So let's check the second row. 2x minus 3, that's wrong. We found out the y-intercept's -3, not -1. So this is the only one that's correct for the second row. That means by process of elimination, we've got our answer. Okay, so look, this is saying y equals 7. If you remember, y equals 7, I think a lot of you know how to put that on the y-axis. That's a dot right here. But look, this is also where y equals 7. That's 1, 7. This is 2, 7, 3, 7. So this is the line when y equals 7. Okay? But this line only exists when x is less than or equal to -1. So here is the horizontal line for y equals 7. But it only happens when x is less than or equal to -1. So it's going by 2's on the x-axis. So I want my dot right there. That line stops at x equals -1, and then we switch to this other piecewise function. This piecewise function says y equals 4 when x is between these two numbers. So y equals 4, and that's when x, this is not included because it's an open circle, right? Y equals 4 when x is between -1 and +2. And then another open circle over here because it doesn't say or equal to. And then this one, 2x minus 5, it's got a y-intercept of -5. And then a slope of 2, which means we go here from this dot, we go up 2 to the right 1. Up 2 to the right 1. But this line is only supposed to exist when x is greater than 2. Right now it happens at x equals 0, at x equals 1, so that can't happen. So you've got to shift the line without losing your slope. You need a slope of 2. And I think that's it right there, okay? Because this has a slope of 2. Go up 1, 2. Remember, you're counting by 2's in the y-axis, so up 2 to the right 1. That's a slope of 2. If you go in reverse, if you go to down 2 to the left 1, down 2 to the left 1, that would cross at y equals -5. And then we need a closed dot because it says the or equal to symbol. So I think we've got this graphed. That's a tough one to graph, though. Was there any else in this section? Okay, that's it for piecewise functions.